function that is twice differentiable for all real numbers. The table above gives values of f for selected points in a closed interval. 2 is less than or equal to x, and 13 is greater than or equal to x. Letter A, you have to estimate f prime of 4. All you have to do is the slope. y2 is negative 2 minus 4 over 5 minus 3. It equals negative 6 over 2. And the overall answer is negative 3.
Go.
Let f be the function that is twice differential for all real numbers. The table above gives values of f for selected points in the closed integral of 2 greater than or equal than x and greater than or equal to 13. In number B, you have to evaluate the integral of 13 and 2, that is 3 minus 5 f prime of x dx. You have to rewrite the function as integral 13 over 2 of 3 dx minus 5 over the integral of 13 over 2 of f prime of x. Then you have to separate them into x, 3 of x, and 13 over 2. Then you have to do the 3 times 13, that is the first part, and then you gotta minus it by 3 over 2, that is 39 minus 6, that equals 33. And for the other part, you have to have the negative 5 of fx of 13 and 2. Then you have to plug in the negative 5 of f of 13 minus f of 2, that equals negative 5, 6 minus 1, that is negative 5, and 5, that you have to times it, that equals negative 25. Then you have to subtract 33 minus 25, that equals 8.
Let f be a function that is twice differentiable for all real numbers. The table above gives values of f for selected points in the closed interval 2 less than or equal to x less than or equal to 13. For letter C, it says, use a left Riemann sum with subintervals indicated by the data in the table to approximate interval 13 and 2 f of x dx. Show the work that leads to your answer. So for interval 13 of 2 f of x dx, you would need to find the distance between 2 and 3 and the value of f of x. So in this case, with the distance between 3 and 2 would be 1 times 1 to get f of 2. Since you're using left Riemann sums, you would ignore 13 because there is no value to the right. Same for 3 and 5. To get the value of 5, which the distance between these two would be 2 times 4, indicated right here. The distance between 5 and 8 would be 3 times negative 2, right here. Plus the distance between 8 and 13, which is 5, subinterval 3, f of x. Multiply these together and add them to each other to equal 18. Final answer, integral 13 to f of x dx equals 18. Suppose f prime of 5 equals 3 and f double prime of x is less than 0 for all x in the closed interval where 5 is less than or equal to x less than or equal to 8. Use the line tangent to the graph of x equals 5 to show that f of 7 is less than or equal to 4. Use the secant line for the graph of f on 5 is less than or equal to 0, less than or equal to 8 to show that f of 7 is greater than or equal to 4/3. You use the slope formula y sub 2 minus y sub 1 over x sub 2 minus x sub 1 on the points right here, 3, 4, and 8, 3, to get 3 minus 4 over 8 minus 3, which equals negative 1/5. You plug that in into the y equals mx plus b formula, and you get 4 equals negative 7/5 plus b, which equals 27 over 5 equals b. You once again plug it into the formula, y equals negative 1/5 x plus 27/5, ultimately leading to negative 7/5 plus 27/5, which equals 4. 4 is greater than or equal to 4/3.